So before we start to work this out, let's talk about what topics you need to know to be able to do this question. Alright, so the first thing you need to know how to do is how to expand brackets. Okay, so how to expand brackets, that's the first thing you would need to know how to do. The second thing you would need how to do is how to simplify algebraic expressions. Okay, how to simplify algebraic expressions. The third thing you would need to know how to do is how to solve equations, alright, simultaneously. Alright, how to solve equations simultaneously. Of course, in part of that, right, so part of that would be how to transpose, right? Transpose meaning you would more know it as making something the subject of the formula. Okay, all right, so make something the subject of the formula, right? Right, and you will also need to know your how to solve quadratic equations, right? How to solve quadratic equations. I'm going to use short form here. How to solve quadratic equations, right? And to do this, you would need to know how to factorize, all right, quadratic equations, or how to use the quadratic formula. Okay, quadratic formula. Alright, and the last but not least, the other topic you would need to know is SURDS and the rules. Okay, all the rules for manipulating and working with SURDS. Alright, we wouldn't be using all the rules, but you would see some come into play here. Alright, let's see. Alright, yeah, and of course a little bit of critical thinking. Okay, critical thinking here, right? Okay, so let's get started working out this question. So I'm gonna take this question here, put it on a new page. Great. So the first thing we want to do is expand these brackets. So I'm gonna rewrite this part here. A plus the root of 5 multiplied by 3 plus b multiplied by the root of 5. Okay, and I'm gonna expand these brackets here. So a multiplied by 3 will give me 3a. Okay, plus the root of 5 multiplied by 3 will give me plus 3 multiplied by the root of 5. Okay, and then I'm gonna take the a and multiply it by positive b, the root of 5. This will give me positive a b multiplied by the root of 5. Then I'm gonna take the positive root of 5 and multiply it by b, the root of 5. So we know that from our third rules that the root of 5 multiplied by the root of 5 will give me 5, and then we have this b. So what I have here is 5b. Okay, so that rule there, the root of 5 multiplied by the root of 5 will just give me plain old 5, right? Okay, and now we need to simplify this. Now we're trying to get this form here, alright, in order to find the possible values of a and b, this a and this b here. Alright, so let's see if we can rearrange this or simplify it somehow that we get it into a form where we have this constant at the front being added to a number multiplied by the root of 5. Okay, so let's rearrange. I'm gonna put the terms without the root of 5 in it on one side. So I'm gonna start with that 3a plus 5b, right? Then I'm gonna put the other two terms, which are 3 the root of 5 plus ab the root of 5. Alright, So another rule here, right, when we have this same SURDS here, is to factorize out that root of 5. So this will be 3a plus 5b, not touching that, and we're going to pull out that root of 5, and we're going to put everything else there in brackets. So that is 3 plus ab. Alright, now I'm going to rewrite this 26 plus 11 multiplied by the root of 5. So now are we seeing that this here would correspond to the 26 and this part here would be 11. Okay, so the next thing to do now is to make two equations, right? So our two equations would be 3a plus 5b is equal to 26, and the other one, so this will be 1, and the other equation would be the 3 plus ab is equal to 11. That will be our second equation. Okay, so now we need to solve these two equations. Right, so I will take this and put it into our next page, and we will solve them simultaneously. Alright, so I want to solve for a first. Okay, so I'm going to solve for this a here first. So in order to do that, I would need to make a b the subject of the formula, and then substitute that back into another one of the equations, thereby eliminating the b from that one and then solving for a. Alright, so let's look to see who would be easier to use. Okay, so I'm going to say from equation 2, alright, I'm going to make b here the subject of the formula. So alright, first thing I will do is move across this 3. So it's plus there, so it becomes negative here. Alright, and the a is being multiplied by b. Alright, so if I make the b subject of the formula here, so 11 minus 3 is 8, and I divide by the a. Alright, so I made my b the subject of the formula here, and this is my third equation, which I will now substitute into the equation that we didn't use yet, which is equation 1. Alright, so this will be 3a plus, wherever I'm seeing b, I'm going to put in 8 divided by a. So that's 5 multiplied by 8 divided by a, which is equal to 26. Now I'm going to solve for a. Alright, so I need to move this a from the denominator. First, we're going to simplify, expand that brackets, okay? So this will be 3a plus 5 multiplied by 8 will give me 40 divided by a, which is equal to this 26 here. Now I need to move this a out of the denominator. So what I will do, to do that, I will multiply this entire equation by a, okay, not 2, by a. So this will give me 3a multiplied by a will give me 3a squared plus 40 divided by a multiplied by a will give me just plain old 40, and the 26 multiplied by a will give me 26a. Alright, now do we see that we have something resembling a quadratic equation, right? So I'm just going to rearrange this so that it is in a quadratic, right? So this 26a here will come across here, be minus 26a. This 40 will remain positive, and we have equal to 0 on this side, right? So now we're going to solve for this quadratic. We're going to solve this quadratic equation, and we spoke about the two ways we could do this at the beginning, right? We talk about we could either factorize it, all right, factorize, or use a quadratic formula. Okay, so I'm going to do it both ways for you. All right, I'm going to start with factorizing first. So let me just put this onto another page. Right, and I'm going to solve this using factorizing method first. Okay, so sometimes students like to call this method the AC method. All right, what I mean by AC method is that when we label these things A, B, C, to factorize we usually find two numbers that when we multiply it, it gives us the product of our A, which is this 3, multiplied by the C, which is 40. Okay, so we need two numbers that when multiplied will give us a positive 120. Alright, and the two numbers, the same two numbers when added, must give us minus 26, our B. Alright, so how do we go about doing this? Now some students find this really hard to do, okay, and it takes a lot of time because they do trial and error. Okay, so some students just use the quadratic formula. Alright, but let's try. So we need two numbers that when multiplied will give me 120 and when added will give me minus 26. So what two numbers when multiplied will give me 120? Well, let's see, we have 10 and we have 12, right? 12, right? So when we multiply these two, we will get 120. But does 12 plus 10 give us minus 26? No. Okay, not even the negatives of them giving us 26. Alright, let's try 30 and 4. Okay, 30 and 4. Now 30 multiplied by 4 will give me 120, and 30 plus 4 would not give me 26, right? Now even if I make this a negative 30, right? Now negative 30 plus 4 will give me minus 26, right? But if I multiply negative 30 by 4, I will not get positive 120. Okay, so this one as well is out. Alright, so there are a lot of ways depending on the factors of the number that you're using to find two numbers that could do that, right? Alright, so what two numbers again we could use? So let's try 20 and 6. Alright, so 20 multiplied by 6 will give me 120. Alright, and also negative 20 plus negative 6 will give me, right, so negative 20 plus negative 6 will give me negative 26, and if I multiply these two I will get positive 120. Alright, so this is what I'm going to replace our B term with. So our question now becomes our quadratic equation now becomes 3a squared, right, minus, let's put it 20x minus 6x plus 40. Alright, and this will be equal to 0. Alright, so I'm replacing this middle term here with the minus 20 and the minus 6. Right, so let's continue factorizing. What is common to both of these here? Alright, so one change. Okay, this here should be a, right? Not x. Alright. Alright, because we have our unknown and our original quadratic equation is a. Okay, now this a here is not this a. Alright, they're not the same. Okay, so 20a, right? So 20a, right, and 6a, not x, right? Because our unknown term they gave us is a. Okay, now let's continue factorizing. What is common to both 3a squared and 20a? The only thing common there is a. Alright, so I'll pull that out. I'll get 3a minus 20. And what is common to both here? Well, we could pull out 2. Alright, I'll get positive 3a and I'll get negative 20. Okay, so you need to know how to do these things, how to factorize, right? So a minus 2 and 3a minus 20 are your factors. Now let's solve for a. So in order for a minus 2 to be equal to 0, a must be equal to 2. Alright, positive 2. Right? So now when a for 3a minus 20 to be equal to 0, then a must be equal to this 20 here divided by 3. Alright, so here we have two possible values going back to our original question. Alright, so now and again, after you do a long set of working, so go back and look at the original question, right? So the original question was find possible values for a and b. So we found two possible values for a. Alright, the first one is a is equal to positive 2 and a is equal to positive 20 divided by 3. Now we're going to solve for b. So let's go back to the previous page, right? And here, remember we did this working here and we found an equation in terms of with b being the subject of the formula, right? So now we're going to substitute our a values back into this one. So it's b is equal to 8 divided by a, right? So b is equal to 8 divided by a. So let's call this a1 and a2. So the value for b1 would be 8 divided by a1, which is 8 divided by 2, to give me a positive 4 value. My b2 would be 8 divided by a2, which is 8 divided by, right, I'm gonna put it like this, divided by 20 divided by 3. Okay, so primary school maths here, when we have a division sign, we change that to multiplication and we invert. Okay, and when we simplify this, we should get our b value to be, so this would be 6 over 5, right? 6 divided by 5. Okay, so now our two values, right, our a and our b. So b, when a is 2, b would be 4, and when a is 20 divided by 3, or 20 over 3, our b is 6 divided by 5. Okay, and those are the possible values for a and b. So if you're okay with this method to solve for quadratic equations, right, you can stop the video here. If not, I'm gonna do the second way you could solve this question by using the quadratic formula. Okay, so I'll take this to another page and we're gonna solve this using the quadratic formula. So the first thing I want to do is write down the quadratic formula itself. Alright, so usually it starts with x is equal to, but in this case, alright, we're gonna write b. Alright, sorry, we're gonna use this a. Alright, so the blue a, right, remember these two a's are not the same, right? This a is going to be equal to negative b, this b here, which is the 26, alright, plus or minus the square root of the same b squared minus 4 multiplied by a, which is this yellow a, which is the 3, multiplied by c, which is the 40, and all that divided by 2 multiplied by a, and your a here is this 3. Okay, alright, so you have to be very careful with this question. Alright, make sure you're substituting the correct values and you know which values are your a and your b's here. So let's substitute. So b minus 26 plus or minus the square root of 26 squared minus 4 by your a is 3 and your c is 40. Alright, now all this over 2 multiplied by the a, which is 3. Okay, now a common mistake I see students making is that this square root sign does not go over all this. It needs to go over all this working here, right? And your vinculum here needs to go under this entire numerator here. Alright, be careful with that. So minus 26 here becomes positive 26, so I'll just write 26 plus or minus. So 26 squared here should give me 676, right? 4 multiplied by 3 multiplied by 40 should give me 480, right? And all that is over 2 multiplied by 3, which is 6. Alright, let's take off some of this. Okay, so we will have two values for a. Alright, remember all this is equal to a, right? Which is the blue a. So I'm going to put back the a. So your first value for a will be equal to 26 plus, we're going to take the plus, the root of 676 minus 480 should give me 196. Okay, divided by 6. Alright, which will give me 26 plus 14 divided by 6, and this will give me 20 divided by 3. Alright, you can put it back as a mixed fraction if you want, okay, but when we need to solve for b, it'll be easier as 20 divided by 3. Alright, and your second value for a, alright, would be the 26 minus the root of 196, okay, which we worked out on this part here, which is 14, right? So it'll be 26 minus 14 divided by 6, and this should give me 2. Alright, so now that we know that our a1 and our a2 is the same, 20 over 3 and 2. So if we go back to our previous page here where we solved using the factorization, right? A is 2 and a is 20 over 3. And when we substitute those values back into b, right, we will get the same 4 and the same 6 over 5 respectively for the a1 and the a2, right? Okay, so I wouldn't do that here. But you see we got the same answers, right? It doesn't matter which one you call a1 or which one you call a2. Alright, what matters is that you keep a1 and b1 together and a2 and b2 together. Okay, so here we have this question solved, right? So let's go back to the original, make sure we solved it. Okay, so given that all this is equal to that, find the possible values of a and b, right? So our possible values for a and b that we found were one was 2 and one was 30 divided by 20 divided by 3. Okay, right, so 20 divided by 3, and the other one, right, and our values for b was 4. Let's just double check that. So values for b when a was 2 was 4 and the other one was 6 divided by 5. Okay, so 4 and 6 divided by 5. Okay, so those are possible values for a and for b.